Composition of functions is another application we can take with functions where we're plugging one function into the other. And when you're dealing with composition of functions, you'll typically see something like this. This is read f of g of x, and this is read the same way, f of g of x. And if you can imagine it, I think this is a lot of times you'll see this notation, but the one that makes a little bit more sense for what you're actually doing will be this one. What you're doing is you're taking whatever is in for the x and replacing it with whatever g of x is. So if you're finding f of g of x, you're plugging in g of x, or whatever that function is, wherever the x is in f of x. I know that's a lot of wordiness and confusingness, but let's try to break it down. So if I have two functions down here, f of x and g of x, and I want to find f of g of x, and again, another way to write this would be that I'm taking the f function and I'm plugging g of x into the f function. What I could do is I could take the g of x function, and this is going to get plugged in for x anywhere there's an x in the f of x function. So to do that, again, if I were to actually write this out now, so we'd have equals, so since f of x is 2 times something plus 3, all we have to do now is plug in g of x in for the x. If there's more than one x, it's got to go in both spots. And now we can simplify this here, so let's try to distribute. So we get 2x squared minus 4 plus 3, and then finally that'll give us that f of g of x is equal to 2x squared minus 1, and that would be the answer to that first piece of the problem here. So f of g of x would be equal to 2x squared minus 1. Now, we could also calculate g of f of x, which now instead we would be plugging into g of x, we'd be plugging in the f of x function. So sometimes it helps to write it out this way if it's not in this form. So in for g of x, whatever this f of x function is going to go in. So we're basically doing the opposite of what we did before. So I've got this f of x function, and that's going to get plugged in everywhere you see an x in g of x. So there's only one x here, so we'll rewrite the g of x function. So g of x looks like this, so something squared minus 2, and that something that's going to go in here will be this 2x plus 3. Now this is going to have to get FOILed out. Again, I'll do that up here. Just if you don't remember the shortcut, I'll do this longhand just to show you guys what we're doing. We'll take the 2x times the 2x, we'll get 4x squared. We'll take the 2x times the 3 and we'll get 6x. This will also give me a 6x, and this will give me a 9. So then the middle will combine to be 12x. So this whole thing FOILed out, if I squared everything down here, would give me 4x squared plus 12x plus 9, and then I'm going to bring down the minus 2. So to finish this problem up, we would have 4x squared plus 12x plus 7, and our final answer here would be that g of f of x is equal to all that stuff over there on the right. So g of f of x, when we plug the f function into the g function, that's what we end up with. And if you ever have to make a number of calculations where maybe we have to find, f of g of 3, and maybe f of g of something else, and I have to reuse this same function multiple times, sometimes it's easier to come up with these formulas first and then plug the numbers in. If I wanted to do this longhand, this f of g of 3, what I would have to do is first plug the 3 into g of x, and that would give me, so 3 squared is 9 minus 2, which is 7, so g of 3 is 7, and then I'd have to plug 7 now back into here, and that would give me 2 times 7 plus 3, so that'd be 14 plus 3, which is 17. So that would tell me that f of g of 3 is 17. Now, an easier way, since we already have this formula, we could just plug it right into this formula that we found for f of g of x. So I could plug this 3 right into here instead, and that would give me that 3 squared is 9, so 2 times 9 minus 1, and 2 times 9 is 18 minus 1, which is in fact 17. So f of g of 3 is equal to 17, which is the same as what we found when we plugged first into G and then plugged our answer back into F. So again, multiple ways to do that. Sometimes it's easier to plug it in separately. Sometimes it's easier if you have a number of calculations to find the formula first. But that's just an introduction to composition of functions.